In this video, we'll dive into an important concept in system design, the rate limiter. We'll break down what a rate limiter is, explore the different strategies and algorithms used, and explain everything in detail. Welcome to Consultant Bot. If you're looking for practical tips and advice that you can actually use, you're in the right place. We focus on giving you the most value in the shortest amount of time. No fluff. Just solid information to help you reach your goals faster. Whether you're advancing your IT career or just eager to learn something new, we're here to help. Subscribe and hit the notification bell so you don't miss any of our quick, impactful videos. Thanks for being here with Consultant Bot. Let's make every minute count. What is a rate limiter? Let's talk about a three-tier application. This kind of setup has three main components: the front end, where the user interface lives, the application layer, which handles the business logic, and the persistence layer, where the database is stored. Now, every time a user interacts with the screen, they're sending requests to the application. But here's the thing, if your app suddenly becomes very popular, you might see a huge surge in the number of requests coming in. Not only that, but you might also face malicious users trying to flood your system with requests to cause a denial of service, DOS, attack. The challenge here is that your system only has so many resources and can only handle so many requests at a time. If you don't manage these requests properly, your app could slow down or even crash. This is where a rate limiter comes into play. A rate limiter controls the flow of incoming requests, making sure that only a certain number are processed per second. This way, your system doesn't get overwhelmed. It can either reject the extra requests outright or queue them up to be handled later. By implementing a rate limiter, you can keep your application running smoothly, even under heavy load or during an attack. Now let's look at the definition of rate limiter. A rate limiter is a mechanism used to control the frequency of operations or requests made to a network resource, ensuring that the rate does not exceed a predefined limit. To summarize why it is required? Firstly, to protect underlying services. Next is to protect resources in distributed systems. Then again, we need to prevent resource starvation. We also need it to reduce operational costs. And lastly, enhance security by mitigating brute force attacks. Rate limiter strategies? Rate limiter strategies are different methods used by the system designers to control the flow of requests to a system, ensuring that it doesn't get overwhelmed. Strategies refer to the overarching approach or method used to decide how and when to limit requests. A strategy defines the overall plan or concept for rate limiting. It is slightly different from the rate limiter algorithms that we will cover in the later part of this video. Algorithms will cover the specific implementation details that make a strategy work. They define the exact steps or logic that the system follows to enforce the chosen strategy. Here are some common rate limiter strategies, and let's look at them one by one. First up is user rate limiting. This is where we set a limit on how many requests a single user can make within a certain time period. If a user tries to send more requests than allowed during that time, their requests might get declined. It's like saying, "Hey, slow down, you've reached your limit for now." Next, we have concurrency rate limiting. This is about limiting the number of simultaneous sessions or connections a user can have. Ever notice how some websites log you out more frequently? That's usually because they want to keep the number of active users under control. If too many users try to log in at once, some might have to wait in line until someone else logs out. Then, there's ID rate limiting. Here, we set limits based on the user type or user ID, which is handy for targeting specific groups. For example, if traffic is high, premium users might get priority access, while free-tier users might experience a bit of a delay. It's a way of saying, we value all users, but some get a little extra service. Now, let's talk about server rate limiting. This strategy makes sure specific servers handle certain types of requests. For example, you might have one server handling user feeds and another handling notifications. Since the feed server might get more requests, it manages that load separately so it doesn't slow down the notifications. Another type is IP-based rate limiting. This limits the number of requests from a single IP address. You've probably seen this when a website only lets you download a file every few minutes. It's tracking your IP and making sure you're not overloading the system. Finally, we have geography-based rate limiting. This is where we control traffic based on the user's location. Let's say you're running a special sale in one country and expecting a surge in traffic from there. You can prioritize those users over others, ensuring that they get faster access during the sale. Rate limiter benefits. Let's talk about why using a rate limiter is so beneficial, and I'll break it down in a more everyday way. First and foremost, a rate limiter is a great defense against denial of service, DOS, attacks. Imagine if someone tried to flood your system with an overwhelming number of requests, hoping to crash your site or slow it down to a crawl. A rate limiter steps in and says, "Hold on, you're sending too much at once," and stops those excessive requests in their tracks. This helps keep your system safe and running smoothly, even when someone tries to overload it. Next up is resource management. Your system has limited resources, whether it's processing power, memory, or bandwidth. A rate limiter ensures that these resources aren't being hogged by a few users or processes. It makes sure that the load is spread out evenly, so everyone gets a fair share, and your system doesn't get overwhelmed. This is like managing a buffet. Everyone gets to eat, but no one can pile their plate too high at once. Now, let's talk about saving money. By controlling the flow of requests with a rate limiter, you avoid overusing resources, which can rack up costs, especially if you're running on cloud services that charge based on usage. By keeping things in check, you're not only protecting your system but also keeping your bills lower. It's like turning off the lights when you leave a room, small actions that prevent unnecessary expenses. Another big benefit is preventing abuse. Without a rate limiter, someone could exploit your system by making way too many requests, whether it's trying to brute force their way into accounts or scraping your data excessively. A rate limiter acts like a bouncer at the door, only letting in a certain number of requests and keeping out the bad actors who try to game the system. Let's not forget about the user experience. When your system isn't overloaded, it performs better, pages load faster, and users don't experience frustrating delays or errors. A rate limiter helps maintain a consistent, smooth experience for everyone, even during peak times. Think of it as crowd control at a concert. Everyone gets to enjoy the show without feeling cramped or pushed around. Finally, using a rate limiter adds an extra layer of security. By controlling the rate of requests, you can spot suspicious activity more easily, like someone trying to guess passwords or exploit vulnerabilities. It's like having a security guard who not only checks tickets but also keeps an eye out for anything unusual, making your system safer overall. Rate limiter algorithms. A rate limiter algorithm is a set of rules or logic designed to control the rate at which requests are processed by a system. Essentially, it's a mechanism used to prevent a system from being overwhelmed by too many requests in a short period of time. Rate limiting ensures that resources are used efficiently, that the system remains stable, and that all users have fair access to services. These algorithms are used to implement some of the rate limiter strategies that we saw in the earlier part of the video. Let's look at the algorithms one by one. The first one is the fixed window counter. It is best used in situations where you need a simple and predictable rate limiting mechanism, and where occasional bursts of traffic won't significantly harm your system. Imagine you have fixed time intervals, like every minute. Each of these intervals is a window of time. The fixed window counter algorithm keeps track of the number of requests that come in during each window. Let's say you have a limit of 4 requests per minute. At 12, the window starts, and the counter begins. If all 4 of the requests are already received by 30 seconds after 12, the rate limiter will allow them to pass. Any new requests received between 30 seconds past 12 o'clock to 59 seconds past 12 o'clock will be blocked. Then, at 12 o'clock and 1 minute the window resets, and the system starts counting again from 0. And this cycle continues as you can see in the diagram. The sliding window counter algorithm is a way to track and limit requests more flexibly compared to a fixed window. Instead of just looking at a strict minute-by-minute count, it takes into account the most recent activity within the last 60 seconds, regardless of when the current minute started. This helps to smooth out traffic and avoid the problem of bursts right at the edges of those fixed-time windows. Let's say the clock starts at 0 minutes, and you're allowed to make 4 requests every minute. You make 2 requests in the initial 30 seconds. So far, you're well within the limit. The algorithm records that you've made 2 requests in this time period. In the next 30 seconds, you make 2 more requests. Now, you've made 4 requests in the past 60 seconds, still within the limit. Now let's consider some time has passed and you are at the 1 minute 30 second mark and you receive 3 more requests. At this point, after processing 2 of the incoming requests, the system knows you're at your max for the rolling 60-second window starting at 30 seconds till 1 minute 30 seconds. Because you've already made 4 requests within the last minute, this request is denied. Now let's consider some more time has passed and you are at the 2-minute mark. You suddenly receive 5 more requests. The system will process the first 2 of the incoming requests but reject the next 3. Because again you've already allowed for requests within the last minute window. Here you can see the window, instead of being fixed, is constantly recalculated based on the current time and hence keeps moving. Next is the sliding window log. It is a rate-limiting algorithm that offers a more granular and flexible approach to controlling the flow of requests compared to simpler methods like the fixed window counter. It's particularly useful when you need to smooth out the rate-limiting process and avoid spikes that can occur at the boundary of time windows. The sliding window log algorithm tracks each individual request with a timestamp and uses these timestamps to determine whether a new request should be allowed or denied. Instead of just counting requests within a fixed window of time, it continuously checks the number of requests in a rolling or sliding time window. Let's see how it works. We have a log or a register, and let's assume that we have defined a capacity of 2 requests per second. When the initial request arrives, we have no logs yet and hence we record the timestamp, which is at 100 millisecond, and the request is allowed to pass. Now after another 100 milliseconds, we receive the next request and the timestamp is logged. The number of entries in the log is 2, which is not larger than the allowed count, and therefore we can let this request to pass. Now another 100 millisecond later a new request arrives. We add the request timestamp, but still do not remove the older timestamps because it is not older than 1 second from the arrival of the latest request. But the log size now becomes 3, which is larger than the allowed limit, and hence we decline the request. Finally, a new request is received 900 milliseconds later. Since the new request timestamp is greater than 1 second compared to the initial 2 requests, we can clear them from the log. Then the new timestamp is inserted into the log. The number of entries in the log is now 2, not larger than the allowed count, and we can let this request to pass. The next is token bucket algorithm. It is a popular rate-limiting method that allows for flexible and controlled handling of request bursts. It's a bit like managing a water bucket with tokens instead of water droplets. Here's how it works. Let us see how the token bucket algorithm works. Imagine you have a bucket that holds tokens. Each token represents permission to process 1 request. The bucket has a fixed capacity, meaning it can only hold a certain number of tokens at any given time. Tokens are added to the bucket at a steady rate over time. For example, if your rate limit is 5 requests per second, the system will add 5 tokens to the bucket every second. If the bucket is full, i.e. it has reached its maximum capacity, any additional tokens generated are discarded. When a request comes in, the system checks if there are enough tokens in the bucket. If there is at least one token available, the system removes a token from the bucket and allows the request to proceed. If there are no tokens left, the request is either rejected or delayed until more tokens become available. The token bucket algorithm is particularly good at handling bursts of traffic. If the bucket has accumulated tokens during a period of low activity, it can allow a burst of requests to be processed quickly. For example, if your rate limit is 5 requests per second, but there hasn't been any activity for a few seconds, the bucket might have accumulated 15 tokens. If 10 requests suddenly arrive, all can be processed immediately, as there are enough tokens to cover them. The leaky bucket algorithm is a rate-limiting technique often used to control the flow of data or requests in a system. It smooths out bursts of traffic, ensuring that the system handles requests at a consistent rate. Imagine a bucket with a small hole at the bottom. Water, which represents incoming requests, is poured into the bucket at varying rates. However, the water only drips out through the hole at a constant rate, no matter how quickly or how much water is poured in. If too much water is poured in too quickly, and the bucket fills up, the excess water spills over the sides. We have to remember some key points. The bucket has a fixed capacity, which represents the maximum number of requests the system can hold at one time. The hole at the bottom allows requests to be processed at a fixed, steady rate, regardless of how quickly they arrive. If requests come in faster than they can be processed and the bucket overflows, the excess requests are discarded or rejected. Let's say you're managing a web server that can handle 5 requests per second. Here's how the leaky bucket algorithm would work in this scenario. The bucket can hold a certain number of requests, let's say 10 requests. And requests are processed at a rate of 5 per second, which is the rate at which water drips out of the bucket. Requests arrive and are placed in the bucket. The server processes them at a steady rate of 5 per second. If requests are coming in at a rate of 5 per second or slower, everything operates smoothly. If a sudden burst of 10 requests arrives all at once, they fill up the bucket. The server starts processing them at 5 per second. Since the bucket can hold 10 requests, no requests are lost initially. If another burst of 10 requests arrives immediately after the first burst, the bucket, which still has 5 unprocessed requests, can only take 5 more. The remaining 5 requests overflow and are discarded. The algorithm prevents sudden spikes in traffic from overwhelming the system by processing requests at a steady rate. It's easy to understand and implement, and it provides predictable behavior, making it suitable for many real-time systems. Comparison. Here we have tried to create a comprehensive comparison of all the rate-limiting algorithms. Feel free to pause the screen and have a read through. The comparison is drawn on memory efficiency, accuracy, ease of implementation, ease of tuning or customization, and lastly if it supports short burst of traffic. The sliding window counter algorithm seems to have the most benefits and thus regarded as the solution of choice for most of the real-world use cases. Thanks for watching. If you found this video helpful, don't forget to give it a thumbs up and hit that subscribe button so you never miss an update. We're here to help you navigate your challenges, and your support helps us keep the content coming. So, if you have any questions, topics you'd like us to cover, please let us know in the comments, or just want to reach out, you can via our email address. Stay tuned for more insights and advice from Consultant Bot. See you in the next video.